Good morning, everybody. Thank you for getting up and being awake. So I'm Michael Brunton-Spall. For those of you who don't know me, I work for the Government Digital Service, which is part of the Cabinet Office in the UK. So I work for the UK government. My pronouns are he, his, and him, and I seem to have inherited the job title of Head of Cybersecurity, unfortunately. Prior to doing this, I was the Head of Technical Architecture within GDS, so I did all the technical architecture stuff. And I'm told that the second scariest words in the English language you can ever hear are that I'm from the government and I'm here to help. The only thing scarier than hearing that is I'm from security and I'm here to help. And since I'm both, that's not a good sign. I want to talk about Agile and security and how we can do security better. But in order to do that, I kind of want to scare you a little bit. So I'm going to take you on a bit of a ride through the state of security, and particularly the state of computer security as it is right now. So what is the current state of security on the internet? It's not really great. If I go back nearly 10 years, this is 2005, 2006. This is a visualization that the Information is Beautiful team put together, which shows all of the data breaches that happened on the internet back in 2005, 2006. And you can see here that people are losing large numbers of records. So we've got AOL lost 92 million customer email addresses back in 2005. What happened here was that a spammer had decided they'd like to email everybody who had an AOL account back in 2005. That was, everybody who was on it. And so they paid one of the sysadmins who worked for AOL $10,000, and they handed over the email addresses of everyone who was on AOL so they could be spammed, which is nice. We have the US Department of Veteran Affairs, who lost a whole bunch of records. And then in 2007, we had the first majorly worrying breach that people remember, which is TK Maxx in the UK. Their point-of-sale system was infected, and they managed to make off with huge numbers of credit card numbers and stuff from those systems. If we fast forward to 2009, you start seeing lots more of these red bubbles turn up. And red bubbles are where, instead of the organization accidentally publishing all the information, which is what they have a tendency to do, what we see is external attackers getting into your system. So those of you may remember in 2010, Sony PSN hack, where the accounts for people who had PSN accounts were stolen from external hackers. We had the Heartland hack from over there. We've got the Steam attack, various things. We're still losing information and systems from internal mistakes. I think we've got Mozilla up here somewhere near the top. Mozilla accidentally open sourced their account database because why not? As we move forward into, this is 2012, we're starting to see increasing numbers of hacks. It's getting bigger and bigger. The number of people affected, Blizzard, we've got Drupal, Script, Twitter, everybody is starting to be affected. And then when I put these slides together earlier on this year, last year, this was, as far as it went, was into end of 2015. And we have the Anthem hack at the top, we've got the eBay hack, we've got the Evernote hack. If I were to reproduce the slides now, we'd be able to add the Yahoo hack, we'd be able to add the department, the Office of Personnel Management in the US, and so on and so forth. What this should tell you is that large companies are losing data at a regular rate. They're being hacked. It is perfectly normal and regular to see news stories about people being hacked by hackers on the internet, by losing their data, losing customer data all the time. It's become the new normal. Like, nobody really doesn't expect it. Do you expect anybody to keep your data safe? Well, I like to think we do expect them to keep it safe, but the evidence is we're not very good at it. And that's only the ones where we're talking about hackers, all the exciting teenagers in their bedrooms. We also have criminal users on the internet. So it turns out if you build a large enough thing with lots of people in, criminals move in. And the criminal elements vary quite a lot. So I'm going to talk about one particular type of criminal activity, which is the game over malware family. Does anybody here have heard of game over before? Hands up if you've heard of game over or Zeus? Oh, not many of you. So Game Over or Zeus was mostly considered to be a banking malware. So what it does is you get it on your machine, and it sits on your machine, and it finds your browser, and every time you view a website, it can change the website. So what you get is you get a scripting language. It looks a bit like this. So when you go to your bank system, it'll say, when I hit the URL that matches this, what I'll do is I'll go find the password entry, and before that, I'm going to insert a new input that says, please enter your PIN. For the user, they have visited their bank's website. It's HTTPS, it's got a green padlock, it looks safe, but their bank is now asking them for their PIN as well as their password, but it's their bank. So they hand over their PIN, and the malware intercepts the PIN on the wire because it's on your PC, and then takes it off and submits it back to the attacker. That's quite a neat piece of malware. It can do all kinds of interesting things. Game Over was taken down by a joint operation between across Europol, the US and the UK and various other places where we took over the command and control systems. But what I think is interesting about Game Over, and the thing that should actually scare you, is that the Game Over malware wasn't just a single criminal organisation. It turns out to be a subject of a criminal economy. So if you want to steal somebody's banking details, you could write some malware, infect people's machines, steal their banking credentials, log into their online bank, and transfer money to your bank. The problem with that is there's a good possibility you're going to get caught. You know, chances are, if you start transferring money around, you're not going to have all the abilities to do all of the stuff you do. So what we have is we actually have a criminal economy that goes on. So malware authors, the people who wrote Game Over, don't ever use it. They just write it, and then they sell it to various other criminals who decide they'll infect people. Spammers will spam lots of people and attempt to get people to install the malware, but they don't use it themselves. What they do is they treat their infected users essentially a bit like Amazon. They will sell you infected PCs by the hour. And you can go to their website and you can say, I want infected PCs, but I only want people who bank with Royal Bank of Scotland, or I only want people who bank with Bank of America. And they'll say, here's 5,000 computers. You can have them for 2 days. And then as a user of that, you can submit your own scripts to this malware, and then they will install it on 5,000 computers, and then that will harvest a bunch of details. But you probably don't want to then use those details yourself. You're going to resell those as well. So this is an example from the Zeus Trojan as to how the whole process works. And the number of steps in here are quite large. But one of the things that happens when you actually get to this point is people start selling them online. So you can go to online organizations and buy yourself some cards. In fact, you can buy yourself dumps of 1,000 cards at a time with all the card data. One of the interesting things about this, again, is that the Zeus Trojan has, as well as being sold by the malware authors, they pay for technical support. So when I buy it, I not only buy a piece of malware from a criminal organisation, I pay them for technical support. And if I install it on somebody's computer and it's not correctly interfering with the bank's website, I'll phone up a number and somebody will go, hi, can I help you? They're probably based in India because, you know, all good technical support's based in India. They'll be, can I help you? I'm trying to steal these bank details and it's not quite working, and they'll walk you through how to configure it, and they'll go, oh, you probably haven't got that right. And this is what the economy is like. There is enough money in doing this that organizations can have their own technical support, they can run their own things. There is, in fact, a second black economy in people trading pirated copies of the malware. Which is a terrifying thought, that there is enough money in it that people will then go and pirate the copies of the malware, which means you might get malware that misbehaves because the person who bought it, it has a logic bomb in it to make sure it's not pirated. This is the world that we're living in. And then we move to advanced persistent threats, which is a great marketing term if you want to sell people very expensive firewalls. The idea of an advanced persistent threat is a term that I think FireEye came up with, but all of the major security vendors are following as well, which is we'll name organizations that do really high-level attacks, and we'll give them a fancy name so that you're all scared of them, and then you have to spend a couple of £1 million on security systems to protect yourself. And I'm going to cover 2 advanced persistent threats and the sorts of attacks that they do. And I'll tell you why I'm covering these in a second. So the first one is a group called Fin4. So Fin4 do a fairly traditional style attack. What they start off with is they send an email. They do spear phishing. So they won't send an email to everyone. They send an email normally to 1 or 2 individuals in a company. Attached to that email is a PDF. And they target companies that are mostly accountancy firms or they are legal firms. And this PDF will give them information. It'll say, here is the this quarter's information on accountancy for biochemical firms. And it turns out the PDF will be well written. It will be in business English. It will use complex technical terms that are related to accountancy, but it will include a piece of malware. Once they're on that individual's machine, it will call back out, and what they'll do is they'll rifle through that person's email, and they will then send the same PDF to other people in the organization from the one person they targeted. So now, if you're sat in the organization, you're receiving a PDF from one of your co-workers from their internal account, so of course you're going to trust it and open it. So you open it, and they get onto your machine, and they cross from machine to machine, they start harvesting all the credentials, and they're looking for an administrator. When they get an administrator's credentials, they then use the VPN normally, get into your system, they start rifling around in the system. And what they are looking for, most specifically, is the ability to transfer into the mergers and acquisitions department inside legal firms and accountancy firms. Once they've got there, they look for information about new clients who've come to them to talk about mergers and acquisitions. And the scary thing about Fin4 is nobody really knows why they do this. They get this information, they take it away, and everyone is assuming that they're doing insider trading, that they're then buying shares or shorting them in advance of the merger or the acquisition. But nobody knows who they are, nobody knows why they're doing it, that's only the assumption, but nobody's been able to detect the financial transactions yet, because the financial system is so complicated, you can't work out who they are. So as an organization, this is not the kind of thing where you where you have to think, oh, I'm a government organization, or I deal with military secrets, and therefore I should protect myself. These people are targeting any normal organization that could be being merged, being acquired. So, you know, if you were a startup or in the tech industry, you might consider, you know, being acquired to be quite nice. This is the sort of organization that targets you. And they're very capable. The malware they use is custom written. It's not off the shelf. They don't buy it. It's something they wrote for themselves. That terrifies me to a certain degree, because it makes me start to go, oh, there's some quite nasty people out there and they might target me. And more importantly, we have no idea who they are or why they're doing it or how they're getting money from it, but they must be getting enough money to pay for all of this. The second APT is one called Dark Hotel. How many of you are staying here in this hotel? Quite a few. How many of you, when you signed in, joined the Wi-Fi and it asked you for your surname and your room number? Did you put it in? Come on, I'm sure most of you did. Dark Hotel is an APT. They mostly act in the Asia-Pacific area, and what they do is they hack hotels. They hack hotels' Wi-Fi provision. And what they do is, when you go to that page where you enter your name and your room number, they send you a signed Skype or MSN Messenger update to your machine, sometimes a Windows update, and your machine goes, oh, I need to update. It's all signed, you've got a valid certificate, so people install it, and then they've got your machine, and they've taken over your machine. What is quite scary about them is they don't just come to a hotel like this and say, we'll install it and install it on everyone. They come to the hotel, and only if your name matches one of the ones on their list do they target you. And they're looking for executives and senior technical people in tech companies. They're looking for people in government organizations, NGOs, stuff like that. So this is highly, highly targeted. And the nasty thing about this is you would never know. All you see is you go to your hotel, you sign in with your username and password, and your computer says there's an update waiting for you, which, if you're an executive and you travel a lot, you probably see quite a lot. And people do just install them. It's signed, it's got all the things. The signing, the report you can read is fascinating. The suggestion is they actually broke RSA in order to generate some fake signing certificates, because there's some RSA certificates that are published with weak keys, and that they took the effort to break them in order to generate their own certificates. And that's the kind of thing, that's the kind of advanced attacker who is out there. That is the sort of stuff that they're doing. And that worries me quite a lot, because these people aren't, as I said, they're not attacking governments. They're not attacking people who work in the military. They're not attacking people who work in the intelligence community or stuff like that. They're attacking normal executives, businesses, companies that could be acquired. They're attacking, basically, us. And that's something that really starts to worry me, because, well, let's think about, what does security in most organizations do? How many of you have heard of PCI? All of you? How many of you enjoy or like PCI? Not even one? Oh wait, we've got one person down the front who's a bit like, maybe, you're not a QSA, are you? Yeah, security in most organizations is about certification. It's about making sure I've got the appropriate accreditation, I've got somebody to come in and say, yes, everything is good. It's about PCI. It's about having ISO 27001 or 32,000 accredited systems to make sure that works. If I went back to those organizations who were hacked, Sony, Yahoo, Facebook, Twitter, Steam, etc., anybody think that they weren't already doing this? Nobody. Like, they're all doing this security stuff, this accreditation, this PCI stuff. And my basic premise is that digital security, as we have it right now, doesn't work. It is almost entirely all theatre. And I would hazard a guess that as developers, you probably know this already in your organizations. I joked earlier that the scariest words you can actually hear are, I'm from security and I'm here to help. The reason for that is that most security people aren't helping. They're really not. The systems, the checkboxes, the processes they put in place don't work. And I come from government, and that's a really terrifying thought. The way that security does it is by thinking in this manner. You're going to come up with an idea, and then security are going to go, whoa, stop, you've had an idea. We should do a risk analysis on it. We should understand where the risks are. Are you opening us up to a new risk? Once they've approved that you can have the idea, you'll move on to design, and somebody will draw some nice UML diagrams, because that's how we all build software. And then security will go, whoa, hang on, we're going to have a design review. We're going to check whether you're doing secure things in all the right place. And then you'll get onto writing some code. So you might, in many organizations, somebody somewhere gets told, write this code, and then they write it. And then security go, whoa, the person who wrote it may not have written what was down there, so we'll do a code review. And then you get to put it into the test environment, and they'll go, whoa, we've got to pen test it now. We'll bring in a security consultant who'll charge you a lot of money to run Nessus for a day. And then you'll get a report at the end of it that everyone will ignore, and you'll put it into production. That's how security works for most organizations, most people. You also then have the problem security identified that once it's in production, developers have a nasty, nasty habit of wanting to change stuff. And that can't possibly be allowed. So we have change control boards. This, I feel like I should apologize because the UK government wrote ITIL, and I'm really sorry. This is the ITIL workflow for doing change management. And the key thing for me here is that most of this workflow here, so I'm going to decide we're going to do a change evaluation, and then we're going to move. I shall move back over here a little bit. We're going to move over, and we're going to decide which change we'll do. We'll put it into a change board, which will probably meet in 2 weeks' time. They'll be busy focusing on the changes from last time, so it'll get delayed for another 2 weeks. Then the change board will approve the change. It's only when you get to the far right that anybody considers that you might actually have to write the code that needs to be changed. Because you've got the approval to write it, now you'll write it, and then you get approval to put it into production, and you get through the whole process. And the key thing for me, I've been doing Agile software development for far too long, over 10 years now. And Agile kind of changes everything. Agile means that this doesn't work anymore. And as I would argue, I don't think this ever did work. I think it gave people a really nice false illusion that it worked. But then you get people like me come along and start saying, I want to release software every day. In fact, I'd like to release it 3 times a day. And the people who run change boards start saying, how are you going to do that safely? How will we know that you're not releasing bad software? People like me come along and say, I want to enable my developers to actually log on to the production machines. And the security team are like, how are you going to, that'll break everything. And that's when we have to explain to them very nicely and gently that we've been doing this for a while, they just didn't know. In most organizations anyway. I'm going to take a quick detour before we go into how Agile changes everything, because I want to make sure we're all on the same baseline. I go around and I talk about Agile quite a lot, and one of the things that I've discovered is that thanks to a certain Agile methodology that rhymes with rum, not everybody has the same idea about what Agile actually is. Lots of people have got these kind of odd ideas. So I'm going to take you back to the basics of where Agile comes from. So Agile and most Agile methodologies are designed about saying change matters. We do lots of change in software, and trying to pretend that we don't doesn't work, which is how most other methodologies did. So we came up with the Agile Manifesto, and this was back in 2001, and this was about saying there are better ways of doing this. The things that we have been doing aren't working. That was what they recognized in 2001. It's 15 years later, and I'm still explaining this to government. It takes them a bit of time sometimes. But the ways that we used to do things didn't work. And the key statement in this Agile Manifesto for me is that while the things on the right have value, while the things on the right are useful and valuable, the things on the left have more value. So, processes and tools. It matters that you have a repeatable process. It matters that you understand how your software is deployed. It matters that your tooling is good. But the individuals and the interactions matter more. If your process prevents the individuals from interacting with each other, it's not helping. The individuals and interactions win when you're having a discussion about the process, and if the process doesn't fit those individuals and those interactions, you should change it. It says documentation matters, but working software matters more. You should be sure that you can deliver working software on a regular basis far more than you can produce a requirements document and no working software. Of the two things, we'd rather have the working software. It says that responding to change is more important than following a plan. It says that being able to recognize the changing landscape in which we write software is far more important than it is that we follow the original plan. Building a plan is helpful. It helps us understand what's going to, or guess at what's going to happen in future. But I've never ever seen a Gantt chart that represents what is actually going to happen longer than the time it took to write it. In most cases, those Gantt charts are fantasy. They're a fantasy map of a world we wish we had. It's like showing me a map of Middle Earth and saying, now we're going to start moving armies around in the UK based on a map of Middle Earth. That doesn't help. Gantt charts don't work that way. But if you want to know where we are, they sometimes do help. So being able to respond to change is more important. And finally, customer collaboration is more important than contract negotiation. Lots of organizations get stuck dealing with the contracts, and contracts are important. They do matter to help you understand how you engage with people, but collaborating is more important. It matters more. So these things, contracts, planning, documentation, processes, and tools, they matter. And in processes, I will include Scrum, because we've got to a place where that's become a magic process that we can't change. But collaboration, change, deliverables, and people are what matter in Agile more than anything else. Agile, to me, is about building software together. It's about getting individuals and teams and ensuring they communicate with each other. It's about getting your developers and your operations people to sit together and talk to each other and not hate each other. It's about ensuring that your product manager and your designer work with you as well. It's about ensuring that everybody in the team understands what is going on. In many organizations, I've done research into lots and lots of organizations, where there are teams of about 1,000 people. We did a review of a major government project. There were over 1,000 people on the project. When we did interviews with all the people on the project, the same names kept coming up. And what we discovered was in that 1,000 people, there were about 8 to 12 people who were actually doing all of the work. And everybody else was basically pointless. And that's true in so many organizations, I discover. That core team tends to be the ones who are really good at what they do, and if you can get them in the same room, get them talking to one another, things get a lot better. It's about support and trust. One of the things I learned in doing DevOps and going through the DevOps movement is that when we first started, sysadmins were very much, you developers can start thinking about, systems administrative stuff if you want. You can tell me about how I can, use infrastructure as code and program my environment, but you're still not getting root on my machines because I don't trust you. And over time, that builds up to systems administrators. People who've been doing this for 10 years who understand this stuff better than I do, help me. They help me as a developer, they support me, but they trust me to not just randomly go onto the machine and delete everything, mostly. They trust me until I do that, and then they ask me to not please log on to machines again. But the whole point of DevOps is building a collaborative environment. It's about support and trust. The other thing I think Agile really pushes towards is simplicity. If you're building software in an Agile way and you have to be able to explain in person what that card indicates, if you're using physical index cards, the view I've always had is the index card, the thing that's on your Agile board, whatever it is that you're using, is a representation for a conversation. It's not the spec. It is a representation that says that's a piece of work that needs to be done and you need to talk to other people about it. But if you're going to talk to people about it, it turns out you have to make things simple. To be able to represent it that way, to be able to do it that way, you have to make it really, really simple. I think Agile is about maximizing the work that's not done rather than maximizing the amount of work we can do. One of the things that Agile pushes us to do is to make trade-offs, to present to the organization, the business, the decision makers and say, You can do this, we can do 12 points of work. You've got 200 points of work you'd like done. Which things are most important and which things shouldn't we do? Dan North, who spoke yesterday, and I think was on the panel yesterday as well, has always said that your code is not an asset. Many organizations view the code that they've written as a multi-million-pound asset that must be protected. But it's not, it's a liability. Anytime you want to change it, anytime you want to do anything with it, the more of it you have, the harder it is to do anything with. So you should be minimizing that liability. You should be writing as little code as possible. And Dan, again, has a thing for saying that Agile is about minimizing the lead time for delivering business value. It's not about writing code. None of my developers' jobs are to write code. It is to solve problems. They do that by writing code, but I want to minimize the amount of code that they write. What does that mean today for Agile? It means people building minimal viable products and services. It means saying, let's build the smallest possible thing we can and then iterate on top of it. We're going to iterate over each product, adding incrementally changing features. We're going to do that in a weekly or bi-weekly rhythm. We're going to keep building on top of that product over and over and over again. But more importantly, we need to get feedback as well. So feedback really matters. So we'll release early and we'll release often. We'll put it in front of real users. We'll start gathering information and understanding what's going on, finding out how the software works and whether it actually does what we expected. Because it turns out we're really, really, really bad at understanding what our customers want. When they say, I would like one of these widgets and I'd like it to be blue, and we make it blue, and they say, did you not hear me? I said green. It turns out that's often because they don't have the language to explain to us what they want, and we don't have the understanding to actually hear them. What works best is to show the users that, and then demonstrate it, and then hear feedback from them, and then change it over and over. We've been doing this in government, in the UK government. So we produced this model that we said every government service should go through. So we said every government service should think about user needs first. So too many government services are based on a governmental need. You go to a site and you have to apply for a visa, or you have to send money to somebody who's in prison, or you have to claim a benefit. Most of the questions they ask are about the questions that they want to know, not about what you need. So we've asked people to start thinking about the user needs. What is it? Why is it somebody's coming to the site? Because it turns out people go to a commercial company. I used to work for the Guardian newspaper, and people had a choice. They could go to the Guardian newspaper for news, or they could go to the Telegraph, or they could go to the Times, or they could go to BuzzFeed, or they could go anywhere online and read the news that they wanted to. But people come to government when they have to. It's very rarely a voluntary thing. Government is often the only provider of that thing. So we said, start understanding user needs, start understanding what people need from you, and then don't just build the thing, because government, again, is, like, we're really bad at it. Like, we've got quite a long history of IT failures, and that demonstrates just how bad we are. But also, we say, do a discovery, do an alpha, do a very small prototype, and start iterating on it. Get feedback really early. We would like people to change them multiple times per week. We use paper prototypes and designs. We mock up HTML pages with no real back end, and we ask people to try it, experimenting through it. We do user research, and we iterate based on that feedback. Is it working? Is it solving the need? We move into beta program, larger amounts of people, and then we go live, and then eventually, hopefully, we kill it, because it's important you kill things. So with that Agile concept, this, I think, is the most transformative change in software development in the last 10 years, is the Agile process. And one of the issues with security is that the security people have been entirely left behind. This concept is alien to most people who work in security, partly because we haven't brought them along, and partly because many of them came up through physical security. So they're very good at telling you how high a fence needs to be, and you don't really iterate building a fence. It's quite hard to do that. You probably don't want to iterate building a nuclear submarine or a power station or whatever either. So they're not used to this world. They're used to dealing with a very highly sensitive, very specialized and regimented area. So in order to give them advice, we started thinking about how we'd done it in the past. And security publications are filled with very specific checkboxes. PCI is a really good example. So you have to go through understanding, following every checkbox. We said that's not working, so we tried principles. So we published a set of different principles, and you can use these. These are all open and public. You don't have to follow them, but we make people in government follow them. So the first thing we said is most important in computing systems is protecting personal data. Like, actually, the majority of security inside a digital system that we build is about protecting the personal data that you keep in it. Everything else is kind of, matters, but that's the crown jewels. If you have put your details in my system, you have a belief and a trust in me that I can protect that appropriately. And we came up with 15 measures, there's a URL at the bottom, and the slides will be available later, that say these are good practices for protecting personal data. Essentially, they boil down to know what data you're keeping, which turns out to be something we had to say, which is slightly embarrassing. Know who has access, and know how you keep it, give or take. And that's the 15 principles in and of themselves. We then said there's some design principles when you're building systems. So we created some security design principles, which is thinking before you start, making sure you actually understand what you're trying to build and who cares about it. Make services that are hard to compromise if you can. But the other thing that we really push on is too many people think if I build a really hard shell or really fancy firewall on the outside, make it hard to compromise, that's all I need to do. But actually, reducing the impact of compromise really matters as well. So it's about doing segmentation. It's about ensuring that if somebody does get in, they can't just run around doing whatever they want, that it's hard to move from service to service, or it's hard for them, once they've got data, to get it back out or to do anything with it. And then finally, make compromise really easy to detect. Make it so that you know when you've been compromised, because we tend to think you're going to be. The evidence shows that people are being compromised all the time. You're not going to win all the time. But if you know you've been compromised, you have a much greater advantage than many other organizations. There was a statistic the other day, and I'm not going to get it exactly right, but I think it was the average time between somebody being compromised and detecting the compromise at the moment is around about 270 days. That's far too long. Like, if we can get that down, if you were running a system and your operations team didn't know whether or not you'd patched something for 270 days, you'd be quite worried. DevOps and those kind of processes help us understand that detecting what's going on really matters. And then we also push on risk management, which I'll go into slightly more detail because I think it's really important. So we came up with 8 main principles for managing risk inside an organization. And this came out of, these principles were published jointly by us and by the information security arm of the UK government, so a part of GCHQ. And it's quite radical for an intelligence organization to say these sorts of things, because we started with principle number 1, accept uncertainty. You're not going to know everything. You can't mitigate all the risks. You're not going to fix everything. So we started there. And for a traditional security organization to come out and start there is quite a major thing. Secondly, we said security needs to be part of the team. It can't be an afterthought. It can't be an external organization or external bit of your company that just works later. 3, you need to understand the risks, and more importantly, your entire team needs to understand the risks. One of the government organizations I worked in, I went into the organization, we were building the software, I said, could we deploy the software to the servers? And they said, yes, that'd be fine. I was like, which servers can I deploy it to? And they said, we can't tell you. I was like, what do you mean you can't tell me? They're like, the number of servers that we have is classified. I'm like, I'm building the software that runs on them. And they're like, yeah, we can't tell you that. The IP addresses were classified. I had a guess. The IP addresses started 192.168. something, but they were like, those are classified numbers. You can't tell anyone about that. So I think it's a security arm. There's a special place in hell for you right now. Development teams are often completely kept in the dark about the risks. They're not told what they're building or what the risks are. A security team somewhere has done a threat assessment and they've said, oh, we're really worried about this particular type of hacker, so we need to protect against them. But we're not going to tell the people building the system that that's what they need to defend against, because to do so would require us to, tell them anything. And security isn't doing that. So we said one of the principles is make sure everyone on the team understands the risks. We said trust decision-making in the team. Put decision-making in the team and trust that people in the team want to do the right thing. The golden rule of retrospectives is that everyone made the decisions they made with the best knowledge they had at the time for the best intention. Like, people want to do good things. People like working for your company. They don't want the company to go bust. They don't want to lose their jobs. They don't want to lose massive amounts of money or open holes in your system, most of them. We'll talk about insiders maybe later. But inside the team, security needs to trust the decision-making. We said that security is part of everything. It's not just a firewall. It's not just a network. It's a thing that needs to happen throughout the entire system. And then we said user experience is important. And in fact, what we said is user experience is most important. Security merely has to be good enough. So we've done increasing research over the last year with passwords in particular, but lots of other areas as well, that show that when security puts in policies that are designed to protect the system but make the user experience worse. For example, if they make sure your policy has a number on the your password has a number on the end. That's pretty common. A security policy, you must have a number on the end. You must change it every month. Those are two pretty common policies. What we found was that pretty much everybody uses the month as the number on the end. I mean, and so if you're going to guess, you've now taken your entropy down from where it was. You've actually made security worse by making that user experience harder. If you insist that people have a symbol, it turns out about 80–90% of people will end the password with an exclamation mark. That's the symbol people use by default. They'll put an exclamation mark on the end because they've written their password and it says, you can't use that, it needs a symbol. And they're like, oh, I need a symbol. What's the closest one? Well, shift 1. That'll do it. So when we put these things in place, the security team think they're making it better. They think they're improving the entropy of your password. But actually, by making the user experience worse, they make the security of the system worse. And there are better and other things that we can do. So we've said that user experience really matters in security. And in fact, we would rather that people had password policies that didn't have those mandated things and people had simpler passwords than we would that they make a bad user experience where the passwords are easier to guess because they follow defined rules. We said you have to audit your decisions. So in an Agile team, that's actually quite easy, but lots of people don't think it is. All those physical cards, stick them in a box somewhere so you know which stories you played and which ones you didn't. We have that information, but know who made a decision, when they made it, and why they made it. Not so you can blame them, but so we just know. Like, how long ago did we decide to patch that thing? How long ago did we decide to put that thing in place? And then understand the big picture impact. So how does Agile help security? How am I doing for time? I'm doing okay. I've got 104 slides, by the way. I apologize. I go through these quite fast. I do take a breath every now and then, I promise. Let's grab some water and I'll give you a second to try and wonder whether I do ever shut up. So how does Agile help in this area? It gives us continual delivery of business value. It means that the business is getting better all the time. Every time we do a release, the software gets better, the business gets better. In order to do that, it means that we're doing continual acceptance of risk. It means that every time I do a release, I'm having to say, there's new risks I'm opening up or new ones I'm closing down. And this is one of the big changes that we have to make when we start thinking about security. So how do we do it? So I've spent the last 2 years or so going around government, working with Agile teams in government, mostly in non-classified spaces. So we do lots and lots of public-facing services, a few bits with classified systems and so forth, trying to bring Agile into those spaces, understand what can happen, what's the best in that area. And the things that we've come up with, the things that work for us, is firstly, the security team, or the security skills and people in security, have to be an enabler of the team. They cannot be gatekeepers. They cannot view their job as to prevent people from doing stuff. Their job is to say yes and, not no. The security team that just says no doesn't work. People will work around them. We know that from user experience. I know that from all the developers I've personally met, all of whom love to work around security controls. I'm sure many of you have done it over the years. The security team that just says no isn't helping anybody in any way, shape, or form. So we've changed our security team. Our security team is now divided into security engineering and security operations and security architecture. Security engineering's job is to build the tools that enable developers to do the right thing. So we're looking at libraries. We're finding the right authentication libraries and saying, this is how you use this library. So this is a blessed library in Ruby, and we're going to make sure it's up to date. We're going to make sure that we've checked it and scanned it. We're building tools that can audit your AWS accounts and make sure that your IAM policies are set up correctly. We're building tools that you can put into your continuous build pipeline that will vulnerability scan your service every time you build it. We're building tools that can help you track risk and help you track what decisions you made. Because our job as security is to build tools to make developers' lives easier. In most organizations, there's about 100-to-1 ratio of developers to security. If security are the gatekeepers, then it's all over. Like, it won't work. That can't possibly work. So our job is to ensure that people can make better security decisions as they go. I think there's a thing of educating people about safety engineering versus security engineering. So security people tend to think that the world is filled with malicious users who want to deliberately do bad and horrible things. And occasionally they're right. Like, just because you're paranoid doesn't mean they're not out to get you. But safety engineering is designed around the assumption that about 50% of your users are stupider than average. Like, safety engineering is the assumption that someone somewhere is going to turn a thing off, and they shouldn't have. And so in safety engineering, you build the system to fail over correctly, to handle failure, to handle people turning things off, to handle people doing things wrong, to handle people making mistakes. It's very rare I've seen a security system that fails gracefully. Most security systems, if there's a mistake in the service, will either fail open because they have to in order to keep the business running, or will just fail completely. Most security breaches happen because the security system didn't handle a failure. So what we try to do is embed that safety engineering thought processes, and actually a lot of the work that was done in safety engineering goes into Deming, it goes into the predecessors of Agile, predecessors of Lean, and the predecessors of DevOps. All of that great work that's in there, the reason that in DevOps we release more often is because we think mean time to recovery is more important than mean time between failure. That's a safety engineering principle. And security is still assuming that we want the minimum time between any given failure rather than an ability to respond as far more important. So we're trying to bring the safety engineering thought processes into security. It's acknowledging that the unit of delivery is the team, that it's not about a set of graphs and Gantt charts and so forth. The thing that will deliver is the team, and therefore the team has to be given the tools needed to do it and do it well. And that security either needs to be in the team or helping the team or get out of the way. It can't be a gatekeeper. It isn't the unit of delivery. The unit of decision-making is the team, that you have to trust the decisions made in the team. A security team may audit the decisions. They may come in and say, can you explain why you made that decision? They may give feedback and advice into the team. But the team is the people who make that decision in the end. The product manager, the product owner, the service manager, they're the ones who make that decision. And one of the key things that we've discovered is that for a lot of security people, they like to focus on basically everything. They like to say that, every bit of code that changes in the system needs to go through them. But the dirty little secret of software development is that software bugs aren't evenly distributed. They're not throughout your code in every possible line. The example I would say is if you want to find a bug in your code, if you grep your code base for the word parse, you're probably going to find some kind of bug there. Like parsers are still really hard to write. People still get them wrong. That's where you'll find a bunch of your security issues, a bunch of areas where you sanitize your input. Bugs are unevenly distributed, and therefore the security team, who are at 100 to 1 disadvantage, need to be focused on the areas where it matters, where they can provide better things. And then risk. Risk is actually what it's all about for security people. Very few developers are ever taught about risk or explained what risk is, that we're actually caring about it. But also, security people they like to imagine that we can get to a zero risk position, that we're never going to have any risk. And we need to educate people that we're okay to accept a level of risk. ISO 27001 says we can do 4 things to risk. We can accept it, we can transfer it, we can mitigate it, or we can avoid it. Which is we can basically not do something, we can do it and accept it, we can do it well, or we can make a third party do it and then sue them if it goes wrong. And that's it. That's all you can ever do with risk. And it turns out like lots of security people would like us to never do anything, and that way there'd be zero risk. The most secure computer is one that's turned off and buried in a concrete well, the way nobody can get to it. Like that's the only way you can ever be totally secure. Anything above that, you're accepting some level of risk. So we need to do that. To do that, we need to educate team to the risks. I've already kind of covered this, but we need to make sure the team knows what the threats are. They need to make sure that the developers understand what they're worried about. Are they worried about script kiddies doing cross-site scripting hacks? Are they worried about SQL injection? Or are they actually worried about somebody sending spear phishing emails to the admins? Are they worried about fraud vectors and people getting money out? If they don't understand what's going on, the chances that you're building the right software are very, very minimal. And the chances that it'll work are very minimal. In order to do that, one of the things I recommend for our Agile teams is they keep a running risk log. In many cases, this is actually as simple as an Excel spreadsheet or a Google Sites or Wiki or whatever. So we keep a risk log saying every risk we've identified and then what we did. And we associate them with stories. So if we know that we've played a story that says allow admins to change other users' passwords, we now say there's a risk associated with that. And we may have decided to accept that risk. We may have said, you know what, allowing admins to do this is more important than the risk it opens. So we now have an open risk in our software. And then at some point later, we'll sit down and the technical architects and the team will be like, we're still really nervous about that. We think that's too big a risk. Can we play a story that requires admins to use a second factor authentication token when they do that? And we'll write that story up and we'll apply it and we'll connect that to the risk log as well, so that we can know that we've now mitigated some of that risk. And we have a document that says this story here and this story here and this story here all connect to the risk. That helps us turn around to the audit team and say, we know what we're doing. We've made decisions deliberately, cognizantly, and in full awareness of what's going on. We know what our current open risk position is. We know what it was 2 weeks ago, and we know what it think it will be in 2 weeks' time or in 4 weeks' time. And obviously, the further out we go, the more we can change. So we're applying those risk decisions per story. Every story that we play, we're saying, does this give us more risk? Does it close risk? And in some cases, when we do this well, the product manager will make decisions to say, I'm not going to play that story this iteration. I'm going to delay it for an iteration while we come up with a better way of doing it, because that risk is too high. It's too great. We think you should apply controls per story as well. So the team, we appoint a security person on the team. So for any given story, they say that developer is going to be the security person, and they review it with a security hat on. And their job is just to say, I'm going to pretend to be security for 5 minutes and think about this from a negative perspective. I'm going to think about how does this open us to risk and what controls can we put in place? So we do that. We also think there's a thing of security debt, which is much like tech debt. So it's, are we building up that debt, and then do we, just like tech debt, you sometimes accept it. It is okay to accept debt, but you have to know what you're doing. So we're building up security debt, and then the team, the product manager will at certain points go, I'm a bit nervous, we've got really high on that, we need to do a bunch of extra stories, and we'll go through that. It's not about hardening sprints, I think they're a terrible idea, but it's about just knowing how much debt you've got. So, moving on from that, microservices brings us to a new place in security as well. So microservices is reasonably famously described by James Lewis as software that can fit in my head. And by that, he normally means an amount of code that's no bigger than this, which, if you're writing Scala, is quite a lot of scary code. If you're writing Java, it's 1 or 2 getters. But the point of microservices is coming up with small systems that are focused on a single business domain. And the key thing, I think, for microservices is they are business-based. And by being business-based, that means that security teams who work inside your organization probably understand them better than they do large computerized monoliths. They understand that business domain. They can tell you about the threats and the risks in that business domain. So that makes things a lot better and a lot easier. They also tend to own their own data if they're done well. They may put it in Mongo, in which case they may own their data. We'll find out later when we query it. But they have their own data representation, and they can apply their own sets of controls on that data. They can decide how much to give out or not give out. So if you have a microservice that manages citizen data, you could decide to not present medical information to just anybody who asks from your service. You can decide to keep that and only allow that to certain users. You can start making access control rules in the microservice inside the business domain where it makes sense to make those rules. They also have quite strong contracts for communication. And that's really useful from a security perspective because it helps you understand whether they're being abused. If you know that microservice A is supposed to talk to microservice B, and it suddenly mysteriously starts making calls to microservice C, something has changed, and that's probably interesting from a security perspective. That's probably something you want to do something about it. And the thing I like about microservices is that simple systems are more secure. By definition, the fewer lines of code you have, the less complex the business domain, the less complex the service, the more secure it is. But, and this is a big but, microservices, and I don't know if Dan's here or if he's still hungover, but microservices are a bit of a lie in a whole bunch of places. There's a thing called complexity theory. So it turns out that we can break down certain domains into 3 areas of complexity. Some things are simple. So a bike is simple. If I turn the pedal, the back wheel turns. Anybody can understand how that works. And even if you add a gear to it, it's still understandable. A car engine is complicated. The interesting thing about a car engine is, while I know nothing about car engines, I'm vaguely aware that I put petrol in, I turn the key and it goes, An actual mechanical engineer or somebody can understand how they work. And they work repeatably and reliably. They're understandable. They might require smarter people than me to understand them, but they're understandable. Traffic is complex. And the interesting thing about traffic is that in the same initial situation, with everybody making the same sets of decisions, very, very, very small changes in the environment will cause massively divergent behavior to happen. When we move to microservices, we like to think that we're moving from a complicated monolith to a whole collection of simple monoliths. But what we're actually doing is moving to a complex distributed system. And complex distributed systems have unexplained and undefined behaviors. And so that makes security a lot harder. But we have some advantages. Security concerns aren't evenly distributed either. Inside your microservices, it might turn out that only one or two of your microservices have real security concerns. You know where the majority of the threats are. In the same way that I would say if you've got a monolith, looking in your code base for parse functions is going to find you a lot of the bugs. In your microservice, looking for your authentication service is going to find you a lot of your security concerns, because everything else is based off that authentication service. If I can get into your system and do over your authentication service, I've won in almost all microservice systems. And in fact, in many current microservice systems, if I can get in at all, I've won, because, security is a thing. Microservices also brings with us a new world of operations and operational difficulty. And I think DevOps and operations is much better for security than anything previous, and I'm going to tell you why, hopefully in about 10 minutes. First of all, infrastructure as code. Is everyone here doing infrastructure as code? Puppet, Chef, Ansible, whatever it is. Hands up if you're doing it. Oh, not all of you. You should all start doing this. So this is how we do it in the government. So this is our Varnish setup, I think. Is it Varnish? Yes. So this is how we configure our Varnish machines. One of the key things is that no systems admin and no developer ever logs onto a box and modifies the Varnish configuration file. We instead go to a code repository and we change this Puppet manifest to say how Varnish should be configured. And why does that matter? Well, it means it's repeatable, and it means we've got an audit log of who changed what and when they changed it. But more importantly, it means that we have infrastructure as testable code, and that starts to really matter. So we can write tests like this one, which confirm this one is, I think this is Apache actually that is double checking, but it confirms that if we configure Nginx with proxy, that the domain names are set correctly, that we haven't just changed the configuration file in a way that breaks the thing we rely on. And that's really important. We can also move up a level and start doing Cucumber-style tests. So these are BDD-style tests that confirm that some of the critical functionality of the site still works when we've changed the infrastructure. So if we change what ports Nginx is living on, or we just add a new route to the system, we can confirm we didn't just accidentally break a behavior of the system that we expected. And that's incredibly valuable for giving us confidence that we make changes. I went to go work in a government department who should remain nameless, but deal with the thing that we might call Max, if you'd like, rhymes with Max. And when I got there, they explained to me that they do 2 deploys a year, once every 6 months. And we said we'd like to deploy a little more often, and they were like, you want to add a 3rd deploy in the year? That might be a bit tricky. We're like, we'd like to deploy like twice a week. Is that okay? They freaked out. They completely freaked out. They were like, you have no idea. It takes us 3 months to prepare for a deployment. We have to finish the software 3 months before we deploy so we can get it into the test environment, we can run all the tests. We went to go meet the deployment engineer who said, I get given a 200-page manual that tells me how to deploy the software. And he has to read through it step by step and do it all. He has to test it in the test environment. He had been there for, I think it was about 8 years. And in total, he'd done 12 deploys in his entire career. He deployed the software 12 times. He said not once did the manual actually match up with what he had to do. Our software team turned up, we started building stuff. Our deployment engineer met him, and this deployment engineer had been in the organization for 12 years, for all this time, and he turned around and he was like, how many deploys have you done yet? Have you done this? And the guy was like, I've only been here 4 weeks. I was like, so how many deploys have you done? He was like, well, I've done 50 now. And my experience is, when it's 2 in the morning, and you've got somebody who needs to do an urgent patch to one of your systems, the one who's been here 4 weeks and done 50 deploys, I'm going to trust a lot more than the one who's been here 8 years and done 12, because he's going to know what to do. He's going to know how to do it on a regular basis. What's my view on rogue state-level players in cyberspace? I don't know. I'd have to check from my comms team what I'm allowed to say. Buy me a beer later and we can talk about that. Is Tor secure? I don't know. I'm not a crypto nerd. I'd say probably. It's more secure than not using it. Sure. Cyber attacks are bad guys. What about protecting from the good ones? For example, government. I think if you're protecting from the bad guys, you're protecting from all bad guys. I don't think you can distinguish. I think it's good security property that we all attempt to make the internet more secure. It's better for everybody. If it makes the people in the intelligence community's life harder, then that's their job to fix that. What they do matters and is important. Making it easy is not a thing we should be doing. It's not a fundamental view. Antivirus, I can't remember complaining. Antivirus is awful. The KiwiCon, which is going on today, one of the Google security engineers described antivirus as, what was the description he used? He used it overnight, and there's an article about it that's quite good, and he just said we should, as the software development community, we should stop allowing people to tell us run antivirus, because it's equivalent to, I can't remember what he said, it's like equivalent to being bathed in dirty water and claiming that's all you need, or something like that. It was outstanding. I'm not going to comment on the top one from Anonymous. Library repos, that is probably one of the scariest things. There's a couple of people, there's a guy called Guy Podjani, who does a talk on NPM and Node security and runs a security piece of software. And he talks about the amount of third-party code that everyone is now running and the amount of trust we have in third-party code. That is probably the next biggest security vulnerability for most organizations. The problem is Maven Central, NPM, Perl repos and so forth. There is no good solution to that unless you particularly want to sit down and audit, tens of thousands of lines of free and open source code. Your best defense there is that it's very hard for anybody to do anything targeted against you. Like uploading an individual breached node library to target you versus a breached node library that will just target everyone. Chances are you're one small actor in a very big variety of people. So hopefully that'll help. And for the rest, grab me afterwards.